Welcome to Unit 7, Lesson 5, Geometric Series. The learning goals today are calculate the sum of the terms of a geometric sequence. Using a formula, find the sum of the series given two terms of a geometric sequence. Determine any term of a geometric series given the sum in one other piece of information. You might have to find n first. Alright, so here is, now these are not correct. This should read geometric sequence. So 1/4, 1/2, 1, 2, 4, and this right here is a geometric series. So 1/4 plus 1/2 plus 1 plus 2 plus 4, just like an arithmetic sequence versus series, the series is the sum of the terms of the sequence. So our notation is this: Sn is equal to T1 T plus T2 plus T3 plus dot 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 plus Tn. And it's also going to be written as, instead of T1, we can write it as A. T2, since it's a geometric, it's A times R, plus T3 is A times R squared. T4 would be A times R cubed, plus dot 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 plus Tn would be A times R to the n minus 1. Where Sn is the sum, so Sn is the sum of the first n terms. Alright, so what's the formula? The formula is right here. Only one formula here, A bracket R to the exponent n, or R to the exponent n, yes, minus 1 over R minus 1. So we're going to do 3 examples here. We're going to go medium, mild, and spicy. Here's our first one. So find the sum. Actually, they're both, this is pretty medium example. It's not, I wouldn't consider this easy. Find the sum of the series 5 plus 15 plus 45 plus dot 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 plus 10,935. What do I have? Clearly I have my A value. My A value is 5. My R value, well, I can divide consecutive terms. So I can do T2 divided by T1. So here I get R is equal to 3. So I have A and R. And what else do I have? Well, I have Tn. The last term here is Tn. And what I need is, I really need n. So I have A and R, what I need is n. So I'm going to use lesson 2's formula. So this formula here, I know Tn is equal to AR to the exponent of n minus 1. So let's plug in what I know. I know Tn is 10,935 is equal to A is 5, bracket 3 to the exponent of n minus 1. Divide both sides by 5. If I divide both sides by 5, I get 2,187 equals 3 to the exponent n minus 1. As I said before, you can always make common bases here. So 3 to the exponent what gives me 2,187? Well, a little bit, I guess, in check here. But if I do that, I get a value of 7. So now that I can have a dance party now. Dance party, Mr. Wills? Yes, you can, because bases are the same, so drop the base. So here I know that 7 is equal to n minus 1. So n is equal to 8. All right. So now I've got A, R, and n. So now I can substitute in to solve for my Sn, so not S8. So S8 is equal to A, which is 5, bracket 3 to the exponent of 8, minus 1, all over 3 minus 1. So here I'm going to have 5, bracket 3 to the exponent of 8, minus 1, all over 2. This gives me 32,800 all over 2. So that means that S8 is equal to 16,400. So that means the sum of this series is 16,400. All right, let's go to another mild or medium example. The third term in a geometric series is 16. So that means I know that T3 is equal to 16. Each term increases by a factor So increases by a factor of this, so this is my R value. Find the sum of the first 10 terms. So 10, this must be my N. All right, so let's use this little bit of information. T3 is equal to 16, so I know 16 is equal to AR to the power of 3 minus 1. So 16 is equal to AR squared. All right, but I know R. I know that R is 0.5, so I'm going to plug that in. So 16 is equal to A bracket 0.5 squared. So 16 is equal to 0.25 A, divide both sides by 0.25. So I get A is equal to 64. All right, so I have A, and I have R, and I have N. So this is now just a substituting formula. So I know S of 10 is equal to, I have my A value now, so 64, bracket 0.5 to the exponent of 10 minus 1 all over 0.5 minus 1. The numerator, if I put that in my calculator, I get negative 63.9375 all over negative 0.5, and so S10 is equal to 127.875. So the sum of the first 10 terms is 127.875. All right, let's go to the last example. This is probably the most spicy one I got here. The last example looks like this. So again, there's the formula. Find the number of terms of the following sequence. Ooh. So what do I have? Clearly I can see my A value. My A value is right here. Great. My R value, I'm going to divide consecutive terms. So if I do negative 1 over 4 divided by 1 over 8, this is really T2 over T1. So my R value will be, a little bit of math here, negative 1/4 divided by, so instead of divided by I can do times, and I do the reciprocal of 1 over 8, so it's 8 over 1. So here I can see that my R value will be negative 2. So I have my R value. All right, R value, A value, and I also have my SN value. This guy right here, this is what it sums up to, so I know my SN value is right here. All right, so what I want to find, it says, find the number of terms. So here, I want to find what N is equal to. All right, so let's do it. Plug in what I know into my formula. Sn, I know Sn for sure. My Sn is negative 1365 all over 8 is equal to, my A value is 1 over 8, bracket, my R value is negative 2, put that in brackets, the exponent of N minus 1, all over negative 2 minus 1. All right, so I have negative 1365 all over 8 is equal to, not much I can do here, but what I'm actually going to do, whoops, let's go backwards a little bit, make things disappear. Okay, the first thing I'm going to do is get rid of this 1 over 8, so I'm going to multiply this whole side by 8. If I multiply this whole side by 8, this 1 over 8 is gone, but I'm going to multiply this side by 8 as well, which means this 8 is gone. So what am I left with? I'm left with negative 1365 equals negative 2 to the exponent of N minus 1 all over, and that denominator is negative 3. So what just happened there? Well, this fraction right here is over 8, so if I multiply by 8, 8 over 8 is 1, so I'm really left with the numerator. Same thing here. If I multiply this fraction, but this is a fraction over a fraction, yeah, but if I multiply this thing, really multiply this whole fraction by 1 over 8, by 8, sorry, this 1 over 8 is gone, because 1 over 8 times 8 is just 1, so that 1 just appears right there, which I don't really need to write anymore. All right, next thing I want to do is I want to cross this negative 3 over, so I'm going to put this negative 3 on this side. All right, so what do I have then? If I cross that over to this side, I'm going to have 4,095 is equal to negative 2 to the exponent of n minus 1. Almost there. Bring this negative 1 over, so I'm going to have 4,096 is equal to negative 2 to the exponent of n. And then, of course, this I can make a common base here, so negative 2 to the exponent of what equals 4,096, so negative 2 here as well. And this guy here must be, doing your calculator, a little bit of guessing and checking, is a pretty big number, but it's actually 12. So here we go, so I know, drop the base, so I know n is equal to 12. So therefore, there are 12 terms in the series. All right, that was enjoyable. Let's go. Homework. Calculate the sum of the first 10. You know what? If you can do, we'll skip question 1. 2 is good. 3 is good. 4 is also very good. Determine if the series is. Calculate that. That's good. Here. And my favorite one here is 16. That's a nice thinker. Put thinking right here. Geometric series T1S. Ooh, this is also a good one. Greatest possible value. So that means there must be maybe two possible values for that, but which one's the greatest possible? And this is like this guy here. Oh, where is it? No. This is like my example 2, where I have to find n first. All right, that's it. Enjoy.